Have you ever done everything right in your garden? I mean, everything. And still watched one of your plants just struggle? Well, the secret might not be the sun or the water. It could be an invisible force right under your feet. So today, we're going to dig into the hidden world of soil pH, the gatekeeper that decides which of your plants will thrive and which ones are destined to fail.
It's a classic gardening mystery, right? You follow all the rules, give two plants the same care, but they have completely different ideas about growing up. It really makes you wonder, what's the hidden variable? What is going on beneath the surface that we just can't see?
Well, that hidden variable is what we're calling the soil's invisible mood. Yeah, you heard that right. Just like a personality, the soil's mood dictates pretty much how everything in it is going to behave and grow.
You know, we all know to add things like fertilizer and compost, right? But that's kind of like trying to cheer someone up with gifts without actually understanding their mood in the first place. The real power, the real secret, is in the soil's basic chemistry. It's the operating system that decides if those nutrients we add are even usable.
So how do we measure this chemical mood? Well, the answer is a simple two-letter term you've probably heard a million times before: pH. Let's break down exactly what that means for our soil.
Scientifically, it's called soil reaction. But you can just think of it as a constant tug of war happening in the water inside your soil. On one side, you've got hydrogen ions, and they're pulling to make it acidic. On the other side, you've got hydroxyl ions, pulling to make it alkaline. The winner of that little battle determines your soil's entire personality.
Thankfully, we don't need a degree in chemistry to figure this out. Way back in 1909, a Danish scientist named S.P.L. Sorensen came up with a totally brilliant solution: the pH scale. It's just a simple numbering system that lets any of us measure this really complex chemical balance.
And here's how a scale works. It runs from 0 to 14. Simple. Anything below 7 is acidic. That's where those hydrogen ions are winning the tug of war. Anything above 7 is alkaline, where the hydroxyl ions have the upper hand. And right there in the middle, smack at 7.0, that's neutral. A perfect, even balance. Okay, now here's where it gets really surprising. I want you to keep this number in your head: 10. Just 10. Because a change from, say, a pH of 6 to 5 isn't just a small step down. Oh no, it's a huge leap, and this is why.
The reason that number matters so much is because the pH scale is logarithmic. This means that going from a pH of 6 to a pH of 5 doesn't just make the soil a little bit more acidic, it makes it 10 times more acidic. And what about going from 6 down to 4? Well, that's 100 times more acidic. These tiny number changes represent massive, massive shifts in the soil's chemistry. It's a really powerful scale. But why does a plant actually care about this number? This is where the story gets super interesting, because pH is basically the master key to the plant's dinner plate.
The absolute best way to think of pH is as an invisible gatekeeper. Your soil can be jam-packed with all the food a plant could ever want, but if the pH isn't right, that gatekeeper just won't let the plant access any of it.
Okay, think of it this way. In that sweet spot, generally between about 6.5 and 7.5, the gate is wide open. All the major nutrients, we're talking nitrogen, phosphorus, potassium, they're chemically unlocked and ready for the plant's roots to soak them up. But if the pH is too low or too high, that gate slams shut. The nutrients are still there, but they're chemically locked away. The plant is literally surrounded by a feast that it can't eat.
Let's get really specific. In very acidic soil, not only does a key nutrient like phosphorus get totally locked up, but toxic elements like aluminum become soluble, and they can actually poison the plant's roots. On top of that, the processes that make nitrogen available just slow to a crawl. It's a triple threat.
And it's not just about chemistry, it's about biology too. The trillions of microbes that make soil healthy, they're also super sensitive to pH. Bacteria, which are these little nutrient cycling powerhouses, they prefer a neutral environment. But as the soil gets more and more acidic, fungi start to take over. You need a good balance, and pH is the conductor of this whole microscopic orchestra.
So, if pH is this powerful force, where does it even come from? Is it just fixed, or does it change? Let's take a look at the factors that are constantly shaping a soil's personality.
So several factors are always pushing and pulling this number. It starts with the rock the soil was born from, its parent material. But then, life happens. Heavy rainfall washes away alkaline minerals. Even the fertilizers we add can push the pH down over time. It's a super dynamic system, always in flux. But the soil doesn't just give in to these changes. It has its own natural defense mechanism, and it's called buffering. It's like the soil's immune system, constantly working to maintain balance and resist any sudden, drastic swings in pH.
And this buffering power really depends on the soil's makeup. A soil that's rich in clay and organic matter is like a sturdy brick wall. It can take a lot of pressure without changing much. But a sandy soil? It's more like a pile of sand. Its pH can be shifted much more easily.
Okay, so let's bring all this home. How do we use this knowledge to become better gardeners? Well, the key is realizing that a perfect pH isn't just one single number. It all depends on what you're trying to grow.
I mean, just look at the diversity here. Potatoes and tea, they absolutely love acidic soil. Can't get enough of it. Wheat and corn, on the other hand, they prefer conditions that are closer to neutral. And then you get a super adaptable crop like rice, which can thrive in this massive pH range. Knowing what your plant actually prefers is half the battle.
And here's a wild example of putting pH to work for you. There's this common disease called potato scab, and it thrives in neutral soil. But here's the trick. If you grow your potatoes in the acidic soil they naturally love, the disease just can't survive. In this case, managing pH isn't just about feeding your plants, it's a powerful, all-natural form of pest control. How cool is that?
So, if you remember nothing else, here are the 3 key things. First, soil pH is simply that 1 to 14 scale measuring the soil's chemical mood. Second, it is the ultimate gatekeeper of nutrients, no question. And third, while every plant has its own preference, that 6.5 to 7.5 range is the sweet spot where most life absolutely thrives. So the next time you're in your garden, or maybe just walking past a park, look at the plants. But don't just see the leaves and the flowers. Ask yourself, what is the invisible mood of the soil right here, beneath my feet? Because now you know that answer might just be the secret to everything.